Hello everyone. Welcome back to my course Aerospace Engineering, Complete Drone Guide. In this video we will talk about camera GPS drones. Also, I will be thankful if you give me feedback about this course to make it better and more useful for you. Please write down your thoughts in the comment section or reach out to me via the email provided in my profile. The secret behind smooth, cinematic drone footage. When you watch breathtaking aerial footage that feels smooth, cinematic, and almost effortless, it's easy to assume the magic lies entirely in the camera. In reality, the secret is a powerful combination of two components working together in perfect harmony: the drone camera and the gimbal. The camera acts as the eye, capturing everything from sweeping landscapes to detailed close-ups from above. The gimbal, on the other hand, functions like an incredibly steady hand that keeps the camera stable regardless of how the drone moves. Even when the drone accelerates, changes direction, or encounters wind, the gimbal ensures that the footage remains smooth and visually appealing. Without this partnership, even the best camera would produce shaky and unusable results. What is a drone gimbal? A drone gimbal, whether handheld or mounted on a drone, is specifically designed to allow the operator to capture photos and videos without unwanted vibration or shaking. Its primary purpose is stabilization, ensuring that the footage looks fluid and professional. Most modern drone gimbals are powered by three brushless motors, forming what is known as a three-axis system. These axes, pan, roll, and tilt, allow the gimbal to keep the camera level in every direction while the drone is in motion. At the core of this system is an inertial measurement unit, commonly referred to as an IMU. This unit detects movement and sends signals to the motors, which then adjust the camera's position in real time. What makes gimbals especially advanced is the use of algorithms that can distinguish between intentional movements, such as cinematic pans or tracking shots, and unwanted vibrations. As a result, the camera appears to glide smoothly through the air, creating that floating visual effect that defines professional drone footage. Understanding the parts of a drone gimbal. Although different models may vary slightly in design, most aerial gimbals share a similar structure and set of components. By understanding the main components of a gimbal, you can easily navigate and operate most systems available on the market. These components work together to ensure precision, stability, and seamless camera control during flight. Two-axis versus three-axis drone gimbals. One of the most important distinctions in gimbal technology is between two-axis and three-axis systems. A two-axis gimbal stabilizes movement along the pitch and roll axis, which helps reduce vertical and side-to-side motion. However, it does not compensate for yaw, which is the horizontal rotation of the drone. Because of this limitation, footage captured with a two-axis gimbal can often appear jittery, especially when the drone turns. This can result in visual distortions such as the jello effect or rolling shutter issues, which are particularly noticeable in horizontal motion. A three-axis gimbal adds stabilization along the yaw axis, allowing it to correct for rotational movement as well. This additional axis significantly improves video quality by reducing or even eliminating unwanted vibrations and distortions. While three-axis gimbals tend to be heavier, more expensive, and consume more power due to the extra motor, they provide a much higher level of stability and are the preferred choice for professional and cinematic work. Gimbal brushless motors and design. At the heart of every modern drone gimbal are brushless motors. These motors are responsible for maintaining the camera's orientation and responding instantly to any movement detected by the system. Unlike traditional brushed motors, brushless motors do not rely on physical brushes for operation. Instead, they use electronic control systems to manage movement. In a brushless motor, permanent magnets are mounted around the rotor, typically in a cross pattern, which allows for smoother and more efficient operation. One of the key advantages of brushless motors is their efficiency. Since the rotor carries the magnets and does not require direct electrical connections, there is less friction and energy loss. This results in longer lifespan, quieter operation, and more precise control, all of which are critical for achieving stable aerial footage. Additionally, gimbals are usually designed for specific cameras or sensors. This tailored design ensures that the weight and balance are perfectly matched, allowing the system to operate with maximum efficiency and stability. Drone gimbal axis movements. To fully understand how a gimbal stabilizes footage, it is important to explore the three axes of movement it controls. The pan axis, also known as yaw, controls the left and right rotation of the camera. This allows the camera to follow subjects or rotate smoothly during flight. Many advanced drones offer full 360-degree rotation, especially those with retractable arms that prevent obstruction in the camera's field of view. The roll axis controls the side-to-side tilt of the camera. This movement ensures that the horizon remains level, even if the drone itself tilts during flight. Without roll stabilization, footage would appear uneven and disorienting. The tilt axis, also referred to as pitch, manages the upward and downward movement of the camera. This enables the operator to adjust the viewing angle, such as pointing the camera downward for top-down shots or upward for horizon views. Together, these three axes create a fully stabilized system capable of handling complex movements. Damping and anti-vibration systems. In addition to motorized stabilization, gimbals rely on damping systems to reduce vibrations coming from the drone itself. These anti-vibration absorbers are crucial because they filter out medium to high frequency vibrations that could otherwise affect the camera. At the same time, these systems allow low frequency movements to pass through, ensuring that the gimbal can still respond naturally to the drone's motion. This balance is essential for maintaining both stability and responsiveness. While some DIY solutions use materials like foam, rubber balls, or even earplugs, professionally designed dampers are far more effective. High-quality dampers are typically made with durable materials such as carbon fiber plates combined with specially engineered rubber components. Given their importance and relatively low cost, investing in good damping systems is highly recommended. Drone Gimbal Inertial Measurement Unit (IMU). The inertial measurement unit is one of the most critical components of a gimbal system. It continuously measures motion using sensors such as accelerometers and gyroscopes, and in some cases, magnetometers. This data allows the system to detect changes in position, speed, and orientation. The gimbal then uses this information to make real-time adjustments, ensuring that the camera remains stable at all times. Most modern gimbals come with a built-in IMU, which simplifies setup and reduces the need for additional wiring or external devices. However, over time, the IMU can become misaligned, leading to issues such as a tilted horizon in your footage. When this happens, calibration of the gimbal and drone is necessary to restore proper alignment. Beyond stabilization, IMU data also plays a vital role in helping the drone's onboard systems track its position and movement accurately during flight. Drone Gimbal Control Unit (GCU). The Gimbal Control Unit, often referred to as the GCU, acts as the brain of the gimbal system. It processes data received from the IMU and other sensors, then sends commands to the motors to adjust the camera's position. This unit works closely with the drone's flight control system, ensuring that both systems operate in sync. While the flight controller manages the drone's movement, the GCU focuses on stabilizing the camera and maintaining smooth footage. In addition to controlling movement, the GCU also handles video output, transmitting footage to the video downlink so the operator can monitor the live feed in real time. Cameras and sensors. All the stabilization technology in the world would be meaningless without a camera or sensor to capture the actual footage. The camera is the final component that transforms stabilized motion into stunning aerial visuals. Gimbals are typically designed to support specific cameras, and they come with the necessary mounts, screws, and cables to ensure secure attachment and proper communication with the control system. This integration allows the operator to control camera functions such as shutter and recording remotely. Supporting components for gimbal and camera. To ensure reliable performance, additional supporting components are often used alongside the gimbal and camera. These devices help manage power distribution and improve overall system stability. For example, modules with built-in battery elimination circuits (BEC) provide a stable power supply to both the camera and the control unit. This enhances reliability and reduces the risk of power-related issues during flight. When these components are integrated with the drone's flight controller, they contribute to a smoother flying experience. Improved flight stability means fewer vibrations reaching the gimbal, which ultimately results in cleaner and more professional-looking footage. Matching your equipment to your purpose. Selecting the ideal drone camera and gimbal system is not about choosing the most expensive or feature-packed option available. Instead, it is about identifying the system that best aligns with your specific goals and use cases. The needs of someone casually capturing holiday memories are entirely different from those of a professional conducting land surveys or infrastructure inspections. Your primary objective should guide every decision you make. Think carefully about the type of footage you want to capture. If your goal is to follow fast-moving subjects like dirt bikes through a forest, your requirements will differ significantly from someone aiming to film a peaceful and cinematic sunrise over the ocean. Similarly, you need to decide whether factors such as vibrant color reproduction or strong low-light performance are more important for your work. By clearly defining your mission from the beginning, you can filter out unnecessary features and focus on a system that truly supports your creative or professional needs. Systems for hobbyists and content creators. For hobbyists and content creators, ease of use and portability are often the top priorities. Whether you are flying for fun or building content for platforms like YouTube, you need a setup that delivers high-quality results without requiring complex configurations. An integrated system, where the camera and gimbal are built into the drone, is usually the best choice in this case. These systems are designed to work seamlessly together, allowing you to focus on capturing great shots rather than managing technical details. A camera capable of recording in 4K resolution provides a strong balance between quality and practicality, ensuring that your videos appear sharp and professional when viewed online. Equally important is a reliable 3-axis gimbal, which ensures that your footage remains smooth and stable even during movement. In addition, intelligent flight modes such as subject tracking or automated flight paths can significantly enhance your experience. These features allow the drone to handle complex movements while you concentrate on framing the shot and telling your story. Systems for real estate and commercial video. When working in a professional environment such as real estate or commercial video production, expectations are much higher. Clients expect visually impressive results, and your equipment must be capable of delivering them consistently. One of the most critical features in this context is strong dynamic range. This allows the camera to capture details in both bright and dark areas within the same frame. For example, when filming a property, you may need to show a sunlit exterior while also preserving the details inside a dimly lit room. Without good dynamic range, you risk losing important visual information in either highlights or shadows. Smooth and controlled gimbal movement is also essential for producing elegant, cinematic shots that enhance the appeal of a property or product. Slow and predictable motion creates a sense of professionalism and helps convey quality. Higher frame rates, such as 60 frames per second or more, are another valuable feature, as they allow you to create smooth, slow-motion footage that adds a refined and polished look to your final video. Ultimately, investing in a system that directly addresses the challenges of your specific projects will yield far better results than simply choosing the most advanced equipment available. Systems for industrial and professional applications. In industrial applications such as surveying, mapping, or infrastructure inspection, the role of the drone shifts from a creative tool to a precision instrument. In these scenarios, accuracy and reliability are far more important than visual aesthetics. High-resolution sensors are essential for capturing fine details required in tasks like creating 3D models or detecting structural issues. The ability to use interchangeable payloads is another key requirement. Depending on the task, you may need to switch from a standard visual camera to specialized equipment such as a thermal imaging sensor or a LiDAR system. Stability is absolutely critical in these environments. The gimbal must maintain perfect alignment even in challenging conditions like strong winds. Any instability can compromise the accuracy of the collected data, which could lead to errors in analysis or decision-making. Professional-grade drone systems are typically designed with these demanding requirements in mind. They offer enhanced durability, advanced control systems, and the flexibility needed to adapt to different tasks. Choosing such a system should always begin with a clear understanding of the outcomes you need to achieve. Best practices for capturing stunning footage. Having a high-quality drone camera and gimbal is only part of the equation. The way you prepare and operate your equipment plays a major role in determining the quality of your footage. A proper pre-flight routine is essential. Before taking off, calibrating your gimbal should be a standard practice, especially if you have been traveling or operating in different environments. This simple step ensures that your horizon remains level and that the gimbal motors respond accurately during flight. Skipping calibration can result in tilted or uneven footage, which can be difficult to correct later. Optimizing camera settings. Once your drone is in the air, relying entirely on automatic camera settings can lead to inconsistent results. Changes in lighting conditions may cause unwanted shifts in exposure and color, reducing the overall quality of your footage. To maintain full control, switching to manual mode is highly recommended. A widely used principle in filmmaking is the 180-degree shutter rule. This rule suggests that your shutter speed should be set to approximately double your frame rate. For example, if you are recording at 25 frames per second, a shutter speed of 1/50th of a second will produce natural-looking motion blur. This helps create smooth and visually pleasing footage that feels more cinematic. Another important technique is shooting in a flat or logarithmic color profile. While the footage may initially appear dull and low in contrast, it actually retains a greater amount of detail in both highlights and shadows. This additional information provides greater flexibility during post-production, allowing you to perform color grading and achieve a more refined final look. Your goal should always be to capture as much visual data as possible during recording, giving you more creative control when editing your footage later. Mastering cinematic drone movements. The difference between amateur and professional-looking footage often comes down to movement. Fast, abrupt, and unplanned motions can make even high-resolution footage appear unpolished. In contrast, smooth and deliberate movements create a cinematic feel that enhances the viewing experience. When operating your drone, imagine that your camera is mounted on a large, invisible crane rather than a small flying device. This mindset encourages slower, more controlled movements that result in better composition and storytelling. One effective technique is the reveal shot about which we talked before, where you begin with an object in the foreground and gradually move to expose a larger scene behind it. This creates a sense of depth and discovery. Another powerful movement is the orbit, where the drone circles around a subject while keeping it centered in the frame. This technique is particularly useful for showcasing buildings, landmarks, or individuals. A more advanced method is the dolly zoom, which involves moving the drone forward or backward while simultaneously adjusting the zoom in the opposite direction. This creates a dramatic visual effect that can add tension or emphasis to a scene. By combining careful preparation, precise camera control, and smooth, intentional movement, you can unlock the full potential of your drone camera and gimbal system. Instead of simply recording aerial footage, you will be able to craft compelling visual stories that engage and captivate your audience. GPS drones. The evolution of drone technology has introduced a transformative class of aerial platforms known as GPS drones. These are not simply flying machines used for basic tasks. They are highly advanced precision tools that utilize sophisticated navigation systems to deliver high-accuracy performance across commercial, industrial, and defense applications. As industries increasingly move toward automation, location intelligence, and remote sensing, the importance of GPS-enabled drones continues to grow. These systems play a crucial role in improving efficiency, accuracy, and decision-making across a wide range of operations. Understanding what makes a GPS drone valuable is therefore more important than ever for anyone working with or learning about drone technology. What is a GPS drone? A GPS drone is an unmanned aerial vehicle equipped with a global positioning system receiver. This component allows the drone to determine its exact position relative to the Earth with a high degree of accuracy, often reaching centimeter-level precision when enhanced systems are used. This positioning capability enables a wide range of advanced features. These include autonomous flight planning, where the drone can follow predefined routes without manual control, and return-to-home functionality, which allows the drone to safely return to its launch point in case of signal loss or low battery. Additionally, GPS drones support precise geotagging of captured images, waypoint-based navigation, and stable hovering even under challenging environmental conditions. Unlike basic drones that rely only on internal sensors, GPS-controlled drones combine enhanced orientation, positioning, and flight control systems. This makes them essential for high-stakes applications such as land surveying, infrastructure inspection, and tactical surveillance operations. How GPS drones work. The working principle of GPS drones is based on their ability to calculate their exact position by receiving signals from multiple satellites in orbit around the Earth. These satellites form what is known as the GPS constellation. The drone's GPS module receives signals from these satellites and calculates key parameters such as latitude, longitude, altitude, and speed in real time. This is achieved by measuring the time it takes for signals to travel from each satellite to the drone. More advanced drones are equipped with multi-constellation GNSS support, meaning they can access not only GPS satellites, but also other global navigation systems. This improves positioning reliability, especially in areas where satellite signals may be obstructed, such as urban environments or remote terrains. The true capability of GPS drones becomes evident when this positional data is processed by onboard navigation algorithms. These algorithms enable precision-controlled flight paths, automated mission execution, and seamless capture of geospatial data, making the drone highly efficient and accurate in its operations. Key features of GPS drones. Understanding the features of GPS drones is essential for evaluating their usefulness across different industries and applications. These drones offer a range of advanced functionalities that significantly enhance their performance and reliability. Autonomous flight and waypoint navigation allow drones to follow predefined routes without continuous human control. This makes it possible to execute complex missions with high precision and consistency. The return-to-home feature acts as a safety mechanism. If the drone loses connection with the controller or its battery level drops below a critical threshold, it automatically navigates back to its original launch point, reducing the risk of loss or damage. Position hold stability is another critical feature. It allows the drone to maintain a fixed position in the air, which is especially important for applications such as aerial mapping, photogrammetry, and surveillance where steady positioning is required. Geotagging adds another layer of value by embedding positional metadata into every image or video captured by the drone. This data is essential for spatial analysis and is widely used in applications such as mapping and land assessment. Applications across industries. GPS-controlled drones have a significant impact across multiple industries. These drones are not just tools for capturing images. They function as advanced decision support systems that provide valuable data for analysis and planning. Surveying and mapping. One of the most important applications of GPS drones is in surveying and mapping. These drones use photogrammetry techniques to process geotagged images captured from the air. The result is highly accurate outputs such as orthomosaic maps, digital elevation models, and three-dimensional terrain reconstructions. These outputs are widely used in land surveying, cadastral mapping, infrastructure development, and urban planning. The accuracy and efficiency of GPS drones make them indispensable in these fields. Precision agriculture. In agriculture, GPS drones enable the collection of highly accurate spatial data using multispectral and thermal imaging. This allows farmers to monitor crop health, detect stress, manage irrigation, and apply nutrients more efficiently. By providing zone-specific insights, GPS drones help optimize resource usage and improve overall crop yield, making them a valuable tool in modern farming practices. Asset inspection. GPS drones are widely used for inspecting industrial assets such as pipelines, transmission towers, telecommunications infrastructure, and solar power installations. By following predefined waypoints, drones can systematically inspect specific sections of infrastructure. They can also geotag any faults or anomalies detected during inspection, allowing for precise identification and faster maintenance response. Defense and security. In defense and security applications, GPS drones provide continuous situational awareness. They are used for surveillance, reconnaissance, and target tracking over large areas. These drones can patrol along predefined routes and collect accurate data for intelligence missions. The return to home feature also ensures safe recovery in high-risk environments. Types of GPS drones. GPS-enabled drones come in different configurations depending on their intended use. The main differences lie in their payload capacity, flight endurance, and maneuverability. Multi-rotor GPS drones. Multi-rotor drones are ideal for applications that require stable hovering and precise maneuverability at low altitudes. They are commonly used for close-range inspections, aerial photography, and vertical mapping tasks. Fixed-wing GPS drones. Fixed-wing drones are designed for long-range operations. They can cover large distances, sometimes spanning hundreds of kilometers in a single flight. This makes them suitable for corridor mapping and large-scale infrastructure surveys. Hybrid VTOL GPS drones. Hybrid VTOL drones combine the advantages of both multi-rotor and fixed-wing designs. They can take off and land vertically while also offering extended flight endurance. These drones are particularly useful in remote or rugged environments where traditional takeoff and landing are difficult. Accuracy and calibration. The performance of GPS in drones depends heavily on calibration and the availability of correction data. Basic GPS systems typically provide accuracy within a few meters, which is sufficient for general navigation. However, for applications that require high precision, additional technologies such as RTK and PPK are used. These systems provide correction data that significantly improves accuracy, allowing drones to achieve centimeter-level precision. This level of accuracy is essential for applications such as cadastral surveys, infrastructure development, and smart city planning. Role of software in GPS drone operations. Software plays a critical role in enabling GPS drone functionality. It provides tools for mission planning, allowing operators to define flight paths and objectives before takeoff. During flight, software systems enable real-time monitoring and control, ensuring that the drone follows its planned route accurately. They also support automated data capture, reducing the need for manual intervention. After the flight, software platforms are used to process and analyze the collected data. These platforms provide tools for visualization, reporting, and analytics, helping users extract meaningful insights from the data. In addition, software systems help manage data integrity, maintain pilot logs, and ensure compliance with airspace regulations. GPS drones in integrated workflows. The true value of GPS drones becomes evident when they are integrated into larger digital workflows. When GPS-tagged data is directly fed into systems such as asset management platforms, GIS mapping tools, or engineering design software, it creates a seamless process from data collection to decision-making. This integration reduces the time required for fieldwork, improves operational efficiency, and enhances the quality of decisions based on accurate and timely data. Future of GPS drone technology. The future of GPS drone technology is focused on increasing reliability, intelligence, and autonomy. One of the key areas of development is AI-assisted navigation, which allows drones to make smarter decisions in real time. Another important advancement is multi-sensor fusion, where data from GPS, cameras, and other sensors is combined to improve accuracy and reliability. Enhanced GNSS resilience is also being developed to ensure that drones can operate effectively even in environments where GPS signals are weak or unavailable. Future drones are expected to use vision-based navigation alongside GPS, providing redundancy and making them more dependable in complex environments. Conclusion. GPS-enabled drones are redefining how data is captured, processed, and used across industries. By providing unmatched location accuracy, automation capabilities, and scalability, these drones have become essential tools rather than optional technologies. Whether used for mapping remote terrain, inspecting infrastructure, or supporting defense operations, GPS drones are transforming workflows and improving efficiency. Their ability to deliver precise and actionable data makes them a critical component of modern operations. At the forefront of this innovation are companies like Asteria Aerospace, which develop UAV systems designed to operate with high GPS precision even in challenging conditions. When combined with advanced software platforms such as Skydeck, users gain access to real-time planning, seamless data analysis, and actionable geospatial intelligence. This ensures that every piece of data captured from the air contributes to meaningful decisions on the ground. Okay guys, now let's have a little quiz. The quiz consists of 5 questions. I'll give you 10 seconds for each one, and then I'll show you the correct answer. Let's start with the first question. Question 1. What is the main purpose of a drone gimbal? The correct answer is to stabilize the camera and reduce vibration. Question 2. Which system provides stabilization on all three axes, pan, roll, and tilt? The correct answer is three-axis system. Question 3. What does the IMU inertial measurement unit in a drone gimbal do? The correct answer is measures motion and helps stabilize the camera. Question 4. In drone cinematography, what does shooting in a flat or logarithmic color profile help with? The correct answer is preserving more detail for post-production editing. Question 5. What is the main advantage of GPS drones? The correct answer is they provide precise positioning and autonomous flight features. Unlock the world of aerospace engineering with my other expertly designed courses. In aerospace engineering, Basics of Aerodynamics, you'll explore how air interacts with moving aircraft and how aerodynamic forces influence performance, giving you a strong foundation in the principles that enable efficient lift, stability, and control in modern flight. Then, take your knowledge to new heights with aerospace engineering, aerodynamics, and structures, where you'll dive into the design and performance of aerospace structures and their aerodynamic behavior. Finally, expand your expertise with aerospace engineering. Rocket Science Basics, where you'll learn about the fundamental principles that govern rocket design, propulsion, and spaceflight, bridging the gap between theoretical physics, engineering structures, and launch systems. Whether you're a student, aspiring engineer, or aviation enthusiast, these courses will equip you with essential knowledge to understand and contribute to the future of aviation. Join hundreds of learners and start building your aerospace journey today. Thank you guys for watching this video. If you have any questions about this lesson, feel free to ask me in the comment section. I will answer as soon as possible. We can continue to the next lesson and learn about military drones. See you in the next video. Bye.